Today we are moving on to 7.4, so make sure you have a sheet of paper and a pencil in front of you so you can go take notes. If you don't have that in front of you, go get that now. So we're starting in 7.4. We're talking about rational versus irrational numbers. These all fall in the real numbers category. So in 8th grade, you only deal with real numbers. In the future, you're going to start working with imaginary numbers. So you have that to look forward to. But for 8th grade, we are just focusing on these real numbers. And that fits into the category of rational versus irrational, which is what we're talking about today. By the end of this lesson, you should be able to identify if a number is rational or irrational, and you're going to explain to me why that number is rational or irrational. So let's get started. So let's talk about these real numbers. This fits into the category of all real numbers. So we have two different things that these real numbers break into. It can either be a rational number or it can be an irrational number. And there's some examples. We've talked about the rational number category. I'm just introducing irrational numbers to you today. But let's do a review on these rational numbers. So a rational number can be any number that's written as a fraction. So we can have 3/8, we can have -5, we can have our counting numbers, 1, 2, 3, 4, 5. We can have decimals, 2.7. We can have decimals, and we can have the number 0. For irrational numbers, we kind of focus on two different things. We have the number pi. So we know what the number pi is, 3.14159, so on and so forth. And then we also have some kinds of square roots. So I gave you two different examples of square roots that would be considered irrational numbers. And we'll get into that in a little bit. This rational number category actually gets broken up a little bit further. That's why it's a little bit bigger, because I've got more information to put in there. So for rational numbers, that's the overarching category. We can take some of those numbers and classify them so they're a little bit more specific. So think about when we talk about quadrilaterals. Quadrilaterals means we have 4 sides. We break those up into more specific things. Like a square is a quadrilateral, but a square is a very, very specific one. It has to have all the same sides and it has to have all right angles. A rectangle is also a quadrilateral. And so it has 2 sides that match up, and then it has all the right angles. So think about like that quadrilateral breakdown when we're going through this rational number breakdown. So we've got all these are rational numbers. Then we get a little bit more specific and we talk about integers. Integers are all the whole numbers and their opposites plus 0. And so this category does not allow for decimals and it does not allow for fractions. So if you have a fraction or a decimal, it only fits in the rational number category. But if you have -5, for example, it fits into both of those categories. We can break it down even more and we can talk about whole numbers. Whole numbers are all the counting numbers, so 1, 2, 3, so on and so forth, and 0. And so for this one, it does not allow for negative numbers. Negative numbers only fits into those two categories. And then our last one is natural numbers. Natural numbers are going to be our counting numbers. So it only matches up with 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. And so if I give you a natural number and I'm asking you to classify that natural number, classify just means that I'm asking what type of number it is. So if I give you the number 3, 3 is a natural number because it fits in the natural. It's also a whole number. It's also an integer. It's also a rational number. And it's also a real number. If I give you 3/8, for example, that's just rational and real. So whatever layer of this it starts on, it goes all the way up and it matches every single other category. So let's talk about the difference between rational and irrational numbers. The biggest difference that I see is when I'm thinking about irrational numbers, I think of the number pi. So if I'm thinking of pi, it's 3.14159, so on and so forth. Pi never ends and it never repeats. Those are going to be the requirements to meet an irrational number. So that's my biggest difference. That's what I think of in my head when I'm trying to think of what an irrational number is. Let's talk about rational numbers now. So what part of the word, or what word is part of the word rational? So look at that for a second, the word rational. Hopefully you see the word ratio right at the beginning. We've worked with ratios a lot. All rational numbers have to have a ratio or a fraction form. So if you can put your number into a fraction form, it's going to be considered rational. So can fractions be expressed as ratios? The answer is yes. Fractions are a very common way of expressing ratios. And so let's look at different categories of fractions. So therefore, a number has a fraction form, it has to be a ratio. So can decimals be expressed as ratios? Hopefully thinking, yeah, duh, Miss Christie, decimals can be expressed as ratios. All you're going to do this is take the digits after the decimal, and that's going to be your numerator. And then whatever the place value is, that's your denominator. So for example, 0.13 becomes 13 over 100 because this last number is in the hundreds place, or the hundredths place. So it's over 100. Another way you can look at it, if you don't know your place values, is however many numbers after the decimal there are, that's how many zeros there are. So if I look after the decimal, there are 2 numbers, so there are 2 zeros. So let's look at some examples. I'm going to work with these, or I'm going to do 3 of these with you, and then you're going to do 3 by yourself. So if I'm looking at this, I'm going to take all of the numbers. I'm going to change my color because that is not visible. We'll do red. We're going to take all the numbers after the decimal point, and that's going to be the numerator of our fraction. And then I'm going to look at the place value. I know this last place value is the hundredth, or the thousandth place. Sorry, it's the thousandth place. Another way you can look at it, count how many numbers are after the decimal until you reach the end. And so there's 3 numbers, so 3 zeros. Let's do this one now. So we've got 0.03. I'm looking at all the numbers after the decimal place. Technically, it's 0.3, but I know I can simplify that to just be a 3. Now I'm looking at the place value. That number, the last number in our sequence, is in the hundredths place, or there's 2 numbers after, so I need 2 zeros. Last one I'm going to do is this one here, 0.6. I'm looking at all the numbers after the decimal place. That's just a 6. That's in the tenths place, or there's 1 number after the decimal, so I'm going to have 1 0. So go ahead and pause the video, try these 3 problems over here. And here are your answers. So for this first one, it's a little bit trickier because it has that 1 out front, but all you have to do is throw the 1 out front and do the exact same thing we did. So 1 and 5 over 10. You could also simplify, or not simplify, but change it to a improper fraction. And so as an improper fraction, that's going to be 15 over 10. So either of those answers work. And then we have the second one. So there are 4 numbers. So I have 4 zeros. And then I just threw that on top. Same thing with this one, except 2 numbers, 2 zeros. Let's look at our next category. So our question is, can integers be expressed as ratios? So integers, if you remember, are our counting numbers and their negatives. So -3, -2, -1, 0, 1, 2, 3. Answer is yes, it can be. So the integer is just going to be the numerator, and then you're going to throw a 1 underneath it to be the denominator. For example, if I have the number 5, it's going to become 5 over 1. So whatever the integer is, in this case a 5, just throw it over 1, and you've got it. So I'll do 2 with you. You do 2 by yourself. So this first one, we've got 7. Throw it in the numerator. Throw it over 1. 7 over 1. Our second one, we've got 300. Put 300 in our numerator and just throw it over 1. And that's all you're going to do. Do these two examples now. And here are your two answers. So you should have gotten 10 over 1 and then negative 4 over 1. Doesn't matter if it's a negative or positive. You're just going to put the negative if you have one. Last question I'm going to ask you for this is, can square roots be expressed as ratios? And this one's a little bit trickier. Our answer is going to be sometimes. So if it is a perfect square root, then you're going to find the square root and it's going to end up being an integer. So if I'm talking about the square root of 36, for example, it's going to turn into the integer 6. And then we just figured out how to turn integers into fractions. And that's my example down there. So the square root of 36 is 6, which becomes 6 over 1. If it is not a perfect square root, we'll talk about that in a second. So let's just focus on these perfect square roots now. And we're going to convert the perfect square roots into ratios or fractions. So I'll do the first one, you do the next two. So this is a perfect square root. We've got the square root of 49. Well, 7 times 7 is 49, so our answer is going to be 7. We're going to be able to turn that into a ratio by putting 7 over 1, and that's going to be our final answer. So do those two problems now. And those are your answers. So the square root of 100 becomes 10, which becomes 10 over 1. And then the square root of 4 becomes 2, which becomes 2 over 1. Whenever a number cannot be expressed as a ratio, we call it irrational, which we kind of talked about at the beginning of this lesson, is irrational numbers. So a non-perfect square root, so we worked with perfect square roots. Non-perfect square roots can't be expressed as ratios and do not have an exact value. So they're going to end up being irrational. That's why we were estimating square roots in lesson 7.1. Because we can't get an exact value. The number pi can't be expressed as a ratio and does not have an exact value. So it's irrational. Whenever you're thinking of irrational numbers, remember that you are looking for something that never ends and never repeats. Never ends, never repeats. That's probably the most important takeaway for irrational numbers. There are a bunch of other irrational numbers though. But in 8th grade, we're just going to be focusing on non-perfect square roots and pi. And so here's a breakdown of what you're looking for in each category. So rational numbers, we work with whole numbers, positive integers, negative integers, fractions, decimals, and perfect square roots. For rational numbers in 8th grade, we just focus on non-perfect square roots and the number pi. So hopefully you understand the difference between those two. There's a couple of different ways you can identify what the number is. So let's talk about that. So I want you to pause the video and answer this question. Come up with some kind of a checklist or a routine that you can do to figure out how you can identify if a number is rational or irrational. And I want you to explain that process to me. So pause the video and answer that question. So you can come up with your own way. The two main ways that I see are looking at rational numbers and looking for irrational numbers. So if you understand the rational numbers of putting everything into fractions, you can say, I'm going to take every single number I see and see if I can write it as a fraction. If I can't write it as a fraction, I know it then has to be irrational. Or you can look for irrational numbers and turn everything into decimals and see if that decimal repeats or see if that decimal does not repeat and it does not end. So if it meets those two requirements, then it is going to be an irrational number. If you have a decimal that does repeat or it does end like 0.7, then it's going to be a rational number. So those are the two main ways that I can see to do it. If you have your own way, do your own way. I don't really care. If you have any questions, if you want to check your way to see if it works every single time, just send me an email explaining how you identify whether the number is rational or irrational, and I will tell you if it works or if it doesn't work. If you have any major questions over this lesson, please just send me an email. Have a great day. Bye.